get back to circle geometry land. And when we do, let me quickly just move these things around. When I think of circle geometry, there's three main buckets that I like to think about. So I think about the theorems that involve, if I can move this. I think of theorems that involve the circles in the center. So circles and the center. And then I think about circles and cyclic quads. And then the last bucket that I think of is circles and tangents. Now, sometimes you may have two of the buckets involved, and in the rare occasion, you even have all three buckets involved. But always remember, or always think about, do you know what theorems relate to circles in the center? So an example, one of the ones that deals with this would be like, if you have 2 points and they subtend an angle at the center, and then they subtend an angle at the circumference, well, the angle at the center is going to be double the size of the angle at the circumference. Whereas if we go to circles and cyclic quads, a cyclic quad is just a quad where its vertices are on the circumference. And we know that in a cyclic quad, opposite angles equal 180. And then for tangents, there's three of them, but probably the most, let's just see what a tangent looks like. So if we have a tangent, and then if the tangent links to the radius, and the radius, that will be at 90 degrees. We call that tan radius. And there's a couple of other theorems that go under there, but it's important to keep that in mind. Okay, cool. So let us go and look at a question just to get us moving today. Have we done this one? Let's do this one just to get ourselves warmed up. Find me what X, W, Y, and Z are in this question. And I want you to think about what buckets are involved, what theorem, and then even inside the bucket, what theorem specifically. Okay, Tumelo. Okay, so a lot of students are saying y is 49, and I think we can all see that is because the angle at the center is twice the angle at the circumference. So this one will be double the size of that one. Okay, so that is 49. Which one can we find next? Okay, be careful, Clamelo. This isn't actually a cyclic quad. It's a quadrilateral. It's got four sides, but this one over here is not actually on the circumference of a circle. So we won't be able to use that one there. But it is a quadrilateral, so that could be useful. But good to bear that in mind. All four vertices would have to be on the thing there. So why would X be 41? I don't think X is 41, but I see quite a few students do. I think that this is a tangent, and a tangent that meets a radius, we know a theorem to do with that. We know that X is 90 because of the tan radius theorem. What else can we work out? You are, yes, Letabo, you spotted it, because for the same reason that works, this is also a tangent. And so we can imagine that should be 90 as well. So we're going to say W is 90, tan radius theorem. Now, the last thing, Ngani agrees and Fatejo agrees. Okay, so we got this is 90. We know that is 90. What do we know? Okay, now I know it's confusing, but this isn't a cyclic quad, but what do we know about any quadrilateral? What does any quadrilateral add up to? Any quadrilateral will always add up to 360. Yes. So we can say Z is 360 minus 90 minus 90 minus 98. And that is going to be sum of angles in a quad. And it is going to end up being 82, but that would be the correct read. You can't use the cyclic quad because you don't know if a circle will be able to fit through all of these points. Okay. Give me a thumbs up if you followed in that question. Give me a thumbs. So why isn't it? Okay, to be a cyclic quad, you have to have all 4 of your points on the outside, on the circumference of a circle. Now you'll see that only 2 of the points here are on the circumference of a circle, right? So you'd have to be able to show that a circle can go through all of these points. Okay. Okay, let's see, we've done that one before. Have we done this one? I don't think we've done this one. Can we try and figure out the unknown angles in this situation? And then we're going to go on to an exam type question. Notice how we're mainly figuring out the size of angles at this stage. Okay, so that is a tangent. And that is also a tangent. Keep those answers coming, everyone. Keep them coming. So Lorato, Letty are all saying X is 40. Oh, I see everyone spotted that W must be 90. Yes, so W is 90, and that's going to be tan radius theorem. And then because that is 90, well, if you know that's 90 and that's 50, okay, so we know that that is 40. Okay. We still need to work a bit harder to find Z and Y. So we've kind of worked out. So is Z equal to Y? I think you might be onto something there. Fatejo, why would you think that? I think I might agree, but I want to ask you what theorem are you quoting when you say Z is equal to Y? Tan chord. I agree. So if you figure out Y, you actually know that that tangent and that chord subtend that angle up here. So I agree with you, but we still need to find what Y is. Okay, Humelo has said QP equals PT. Okay, what is the reason that QP equals PT? I need a reason from someone to say why I think these two sides are equal. Tangents from a common point. Yes. Tangents from common point, and that common point is P in this case. So now we know that PTQ is Y, and that is because angles opposite equal sides. So we know they're equal sides and the angles opposite them, so that's Y. And then the last bit would be to say, look, y plus 80 is 180. And that would be sum of angles in triangle. So 2y equals 100, because I've taken away 80 from the sides and I've put the two y's together, and therefore y must be 50. Okay, so if I know that y is 50, what is z going to be? That's the final question for this one. So z is going to be, we discussed this earlier, so that's that one. And then these two are like peas in a pod. So z is 50, and that is tan chord theorem. Yeah. Okay, now let's have another vote. Thumbs up if you're feeling okay with the pace and the general content. Thumbs down if you're feeling a little bit like it's going a bit whoosh, whoosh, whoosh. And I want to see what the ratio is. Just okay. Please explain why Z is 50. I would absolutely be willing to. Let's have a quick look where that was from. So, Owami, there's a tangent over here, and that tangent makes an angle with the chord over here. So there's my angle. But now that chord subtends an angle up here, and that's why these two are, by the tan chord theorem, they have to be equal. So that's why Z has to be 50. Okay. Now, I think it's time to go to a typical exam question. Actually, no, this is a little bit, before we get to this one, let's do, actually, no, it's not a bad idea. Let's do this while we're still fresh. Okay. Before we start this typical exam question, what do we notice about the exam question compared to some of the ones we've been doing so far? Maybe if somebody's willing to comment audibly, just put your hand up or put it in the chat. What do you notice about this question? How many marks? Okay, so we have 2 circles. This question is worth 7 marks for this first questions. And it says, name with reasons 4 other angles equal to X. No given angles. Yeah, so we're now looking, I mean, we can see in the drawing, there is an angle X. Okay, so there's my angle X. And instead of giving us actual numbers, we have to find angles that are equivalent. The diagram is a bit more complicated, so there's a bit more detail in the diagram. And also we have this extra bit of content or text at the top, which explains which is going on in the diagram. So what I like to do with this is I go through the thing. It says in the diagram below, 2 circles touch each other externally at point P. So let me find point P. Point P is here. Then it says QPR is a common tangent to both circles P. So I go, it's almost like I'm introducing myself to the problem. So there is the common tangent to both circles. It also says that EDRC is a tangent to the circle at C. So that's actually going to be this line over there. It says RCA equals Y. So let me just go and find that. Oh, here we go. RCA is down here. That's Y. And we already know that DAC is X. And then it says AD is parallel to BC. Okay, so AD, let's just put, oh, there's the little arrow for the parallel. AD is parallel to BC. So what I've done is I've allowed my brain, instead of it being, it is complicated, the drawing, but I've just taken some time to get to know the drawing, and the colors also help me get a little bit of a feel for it. So what do we think is the first easiest angle to see that is equal to X? Can I zoom in a bit? I can, maybe if that helps. Remember, I'm trying to find 4 other angles equal to A1 or X. So A1 is X, and that is given. We need to find 4 other ones that are the same. So I think the one that most students would gravitate towards is those big purple lines are just looking like they give the game away. And we can say that C2 is X because alternate angles AD parallel to BC. So let's use the same color that I have so far. We're basically saying that this one over here is equal to X. Okay, news. Now, let's give you a moment or two and put in the chat what you think is the other. We need to find 3 more that are equal to either the green one down here or the green one up here. B2 is equal to X. Where's B2? I don't know if I would say B2 is equal to X. B2 because of angles in the same segment. But the problem is with B2, this isn't in one circle. Remember, angles in the same segment have to be inside one circle. So they come from this situation. And the 4 points of the butterfly have to be on the circumference of a circle. And I think this one is between the 2 circles. Now, some people are starting to talk about tan chord. Yes, tan chord. And some people are starting to talk about E. I think I agree with you because this butterfly is inside the big circle up here. So let's see if I can write this down properly. I can say angle E is X, and the reason is angles in the same segment. So this one over here, I'm going to color that in green too. I'll make it an X. And I also know that that was an X. Now, lots of people are saying E in the chat, Ongani and Flamelo. P1, Fatejo and Leti are saying P1. Let's go look at P1. So P1 is sitting down here, and it's the angle between the tangent and the chord. Oh, I see what you're saying. You're saying then I can get that angle over there. And so this one down here must also be an X. So we will say, indeed, we will say P1 equals X, tan chord theorem. Okay, how many have we got so far? We've got 1, 2, and 3. We need 1 more. Who can help us with 1 more? Who wants to put their hand up and give us a hint? Remember, all geometric theorems are in play now, huh? P5, yes, Kia, well done. What's your reason, Kia? I agree with Kia. So Kia is saying that this one over here is also equal to X. So P5 is equal to X. Is it going to be the tan chord theorem? Let's have a look. So the problem is, oh, yes, it is. Sorry, you're right. I can see it now. For the moment, I couldn't see it. So here's the tangent, here's the chord, and it is going to be equal to that one over there. So we could say the tan chord theorem. Or the other thing we said is the vertically opposite. Because it looks to me like, like vertically opposite angles just like are here and here. So you could also say vertically opposite angles. That would also be acceptable. Yeah, Flamelo agrees. There we go. So the last one over here is going to be X. Now, that was quite a bit harder, but it's a very typical exam question where you have to, instead of saying, find me like what this angle is, they say, find me ones that are the same. And I think that was tougher, but I think, you know, we're on the road to understanding this. Give me a thumbs up if you feel okay with this. Give me a thumbs down if you feel a bit lost. Want to get a feel for the room. Now, not all exam drawings will be this complicated, but I wanted to throw one in there. Okay, I like that up down, which means like 50-50. Okay, so let me show you another exam question, but where it's not as complicated as this. And if you are feeling a bit lost here, okay, Kier, let me find you in the chat. Okay, where are you hiding? Yeah. Okay, so let's go to another exam question, which is a little bit less complicated looking. And then after that, we're going to have a break. In fact, maybe we'll even go halfway through this question. So I want you to try this by yourself. And you start by trying to figure out what is the size of R2. And just to make life a little bit easier, I'm going to highlight what R2 is there. So you have a crack. In fact, let's just find what R2 is, and then we're going to take a break. So not all exam questions are as complicated looking as that one I showed you now. But let's just see how this goes. Cool. Andile, I will try and talk. So we're going to talk about proving questions, but I'm not sure if we'll have time to do the formal proofs. What I can try and do is just we're just going to run out of time, and it feels like the proofs there's only going to be one proof out of the 40 marks, and I'll see if I can do some of it if there's time, depending on how much time we have next week. Okay, so we know that QP is equal to RP. So we know that this one is equal to that one, and that is tangents from a common point. Now, what's the next step? Well, we know that basically Q2 must equal R2. So these two must be the same because of angles opposite equal sides. So if your angles are opposite, you can see like that one is opposite that, that one is opposite that. So, and then we can say, we could just call these both X. We could just say X plus 70 is 180. Sum of angles in a triangle. And so X would be 55. So this would be 55, and this would be 55. Okay, so I mean, that was a little bit easier, I guess, than the previous one, but there's all sorts of varieties of questions. What I want is I want to take a break. I feel like we've been working hard, and so to give our brains a break, we're going to stand up, and we are going to, let's put that up. Yeah, we are going to stand up, and we're going to take 3 nice deep breaths. And what I want you to do is just hold when you breathe in at the top, hold for like 3 seconds, and then we'll breathe out again. And then turn your cameras on if you can. All right, let's start. One more breath. Okay, let's just do one more. Okay. Shake out your arms. Just get them nice and loose. Shake out your legs. Let us start with some small circles just to rotate those shoulders. And as you get looser, you can go into big. And then I want you to change direction with the big circles. I want you to go into smaller circles. Okay. Then I want you to stretch your triceps. Stretch it up like this. Shake it out, and then the other one. Okay, feel a little burn in the back. And then let's do some slight rotating. So you just turn a little bit. And then as your body loosens up, you can go a little bit further. But then eventually you feel your body loosen up. Okay. Then, what should we do next? Let's do a little neck stretch. So just head to one side, over like that, then to the other side. Feel like your head's elongating a bit, or your neck is. Okay, shake it out. All right, then let's get our heart rates up. We're going to do air skipping, and we're just going to do 20-ish, and we'll start in 3, 2, 1. Let's go. Halfway. 1, 2, 5 more. And hopefully your body feels like it has had a little bit of a oxygen and blood flowing around. And let's have a look at the Maths 24 problems for today. So for those who are new, Maths 24 is a little fun game we play. This is a 9. So we have 9, 1, 5, and 5. And you have to try and make 24 using these 4 numbers. You can only use each number once, and you only get to use plus, minus, times, divide, and brackets. See what you can do. Red, blue, yellow are all available. Okay, so Ndile and Paul have put forward some ideas. So 9 minus 5 is 4, and that can be timesed plus by, then that's 5 plus 1. So I've used the 9, a 5, a 1, and a 5, and that is indeed 24, because it's just 4 times 6. Perfect. Okay. What about the blue and yellow? What can we do for that? Who has some ideas for the yellow one? So I think there's a couple of ways we could do the second one. So we have 7 times 5 is 35. And then 35 minus 4 minus 7, which gives us 24. So that was Ndile's way. And then there's another way with blue, and Paul said 7/7 is 1. And then 1 plus 5 is 6, and then 6 times 4 is 24. Okay. What about the yellow one? So Kitsaw has said, add the 5 and the 9 together, which gives us 14. Then take away 2. So you've done 5, 9, and 2, and you get 12. And you've still got the 2 left. So 12 times 2 is 24. Yeah. Okay. So the reason I like Maths 24 is it helps us remember our multiplication facts. It's a nice way to get your concentration off the work that we're doing. It's just like a fun little puzzle, like a Sudoku or any of those things. And yeah, so I hope you enjoyed your break. So let's return to this question. And the next thing, and I really recommend when you do these questions, using a highlighter and using some colors can really be helpful for your brain. So here's Q1 is what we want to find. Where is Q1? Q1 is over here. Okay, I want you to try and help me find Q1 here. Okay, Lorato and Letty are all over this one. Can you give me some backup? Ooh, you've spotted that sneaky tan radius theorem. It always catches me. It sort of blends into the background. See if it caught you. So this is a line from the center, or radius, and this is a tangent, right? And what do we know? We know that this is 90. So we would say that QM is perpendicular to QP, and that would be tan radius theorem. Oh, what am I doing? Tan radius theorem. And then, because that's 90, we then know that Q1 must be equal to 35, because you can just say complementary, or you can say adds to 90. Complementary angles, or adds to 90, etc. So this is going to be 35, and yeah, that's going to be correct. That is 35. Okay, what about the last one? What about M2? It's a bit of a tricky one. So I think most of you can see that this is a radius. These are two radii. So that and that would be equal. So that's 35. Now, we know R1 is 35. Now, I was going to say we know that M1, okay, so let's do it like this. We know that R1 is 35, and the reason is radii. So we know that's 35 and that's 35. Then we know that M1 is 110, and that is going to be the sum of angles in a triangle. Now, here's the sneaky bit, guys and girls. M2 is equal to the following. You can't use vertically opposite, because vertically opposite would have to have a straight line there. But there's a theorem that most students don't know about, but it is included. It says, if you have equal chords, so can you see that chord over there and that chord over there are the same, that they are said to be equal? Now, equal chords, there we go, Abongwe, you've got it. Equal chords subtend or build equal angles at the center and at the circumference for that matter. So because these are the same, and M1 is 110, M2 must be 110, because the official reason just goes equal chords, equal angles. And it's basically saying this, it's saying, look, if you've got a circle and you've got a chord over here and you've got another chord over there, and those two chords are equal, those chords will subtend equal angles at the center, even if they're not in line. So maybe if this one was 45, this one, oh, that's too small. But if this one was 80, this one would be 80. And if I had another one here, and it made an angle at the center, it would also be 80, as long as those sides are equal. Okay, that was a tricky one, but it's good to, that's one of the lesser used. So they only subtend angles at the center. No, they actually subtend equal angles at the circumference as well. So if you have two chords that are equal, and by equal that's over there, then that angle over there will be equal to that angle over there as well. Yeah. So equal chords subtend equal angles at the center and at the circumference. Yeah. Okay, I'll give you a moment just to take a screenshot if you want, because I know that theorem is not as commonly used as the other ones. And then we're going to move on to another question. We're building up our stamina and our fitness. Okay, let's do this exam question. You need to find me O1 and O2. So here's O1, and then here is O2. Yes, Sate, it's exactly that. Yes. So it's a corollary. It's related to that. Okay, so O1. Now here's the very sneaky thing, ladies and gentlemen. Oh, but it's such a good question. Here's the chord, and it subtends an angle at the center, and it also subtends an angle at the circumference. These are not angles in the same segment. O1 is not going to be 39. O1 is going to be double 39, which is 78. And our reason is going to be angle at center equals twice angle at circumference. It's so tempting because you see the butterfly. But again, remember, angles in the same segment only work if all four of these points are on the circumference. Well, okay, so the reason is that this theorem is actually the theorem that deals with angle at the center is twice the angle at the circumference. So okay, so they are in the same segment because the one segment is sitting over here and the other segment is on this side. But what's different is that it's not that theorem. That theorem would deal with 39, like that angle up here and that angle over there would be 39 because the 4 points have to sit on the circumference of the circle. That makes sense for Tejo. Okay, so what do we think O1 is? O1 is 78. What is O2 going to be? What is O2 going to be? Let me get rid of some of this. Okay, you guys have got this. I'm glad. Okay, so O2 is going to be equal to 70. So I'm going to keep making it a Q. O2 is going to be 78. And the reason is going to be equal chords, subtend equal angles. So you can see that that chord over there makes that angle. And then that chord over there makes that. So they must equal. It's not that they're vertically opposite. Okay. Give me a thumbs up if you're following this. Give me a thumbs down if you're feeling a bit lost. Just want to see what sort of question I must choose next, because if we're doing okay, it's important. It's like going to the gym. You know, we have to sometimes increase the weights, but depends on how students are feeling in the class. Okay, let's have a look at this one. Okay, this is quite a lot of writing. So what I'm going to do is I'm going to introduce myself to the question. So let's do this. I would suggest doing this in an exam. In the figure, QS and PR are diameters of the circle with O. So let me just, QS is a diameter and PR is a diameter. Okay, such that PQ is parallel to SR. So PQ is parallel to SR. PS is produced to T. That's not really too much of an issue. N is a point on the circle. So where is N? N is a point on the circle such that Q1, so Q1 over here is equal to Q2 over here. It also says RS intersects QN, oh, quite a lot of reading here, at M. S1 is 48. Okay, they've already told us that you can kind of see that angle S1 is 48 over there. Now time for your job. Determine with reasons the size of Q1. So let's try and find what Q1 is equal to first. So you might need to do a bit more work. So because they've told you, let's have a look here. Did they tell you? What did they tell you in the things? Oh, Q1 equals Q2. They've told you that already. Okay, yes. So I think what I would say is that this angle here has to be equal to Q2 by the tan chord. So Q2 is 48 by the tan chord theorem. But we know Q1 equals Q2, and that was given, right? That was up here. Therefore, Q1 must equal 48 degrees. So you're right. That is equal to 48, and that is equal to 48. So that one's done. What about R? What is going to be the size of angle R? So Letabo and Amachle say that R is 48 degrees. Also, Clamelo agrees, Leti, Naledi. Okay, so there's a lot of students are going for 48. Let's see if we can write, oh, I see angles in the same segment. Yes, I see the butterfly, angles in same segment. Okay, so this is 48, and you can see those points are on the circumference. Now, what about M1? M1. What are the other things that we haven't dealt with so far? Oh, let me bring that back. So we know this down here. Well, I want to give you some time. You think about it. So that's 48, that's 48, that's 48. And we want to find M1. Oh, the diameters. Yes. So the diameters make a 90. So that could be helpful. So we haven't used them yet in the question, but you're right. That would be a 90. And this would be a 90. But remember, where is M1? M1 is all the way down here. So what do we think M1 is going to be? Oh, Nashon, that is a good spot. Karabo, you guys are on the ball. Would you like to explain where you get your 96 from? Maybe if you pop your hand, would you be willing to explain, Nation? Just put your hand up if you want to explain, or Karabo. Okay, Nation, can we unmute Nashon? I'm not sure if I'm saying your name right, but Nashon, how would you explain how you get 96?
Good day, sir. How are you?
Very good, very good.
So I added 48 plus 48 because I can see that the QP,
Yes.
are parallel to each other.
Oh, the green parallel lines, yes.
So I see that the angles are corresponding.
Oh, it's the F shape. Yes. It's like hiding in there. So here's the F shape. You can see how it goes through the green, and then the M1 is hidden away. So M1, and if you think about 48 plus 48, so that's 96. Thank you so much. That was very insightful. M1 corresponding angles, and then we say QP parallel to RS. And so now we've got our marks in the bag. Okay, so it is a bit confusing for Tejo, but it's like we're going to the gym and now we're lifting slightly heavier weights. And remember, we can re-watch these things as we go. Okay, but you're doing well to hang in there. Okay, let's see if I can find you. Should we do one more like this? I quite like these questions, and they're all from. Let's do the last one for today. And I'm going to let you fly solo here. I'm not going to say too much. See what you can do. So let's see. So what is angle Q going to be? Let's have a look. I think that Q is indeed, Q is 35 degrees. And the reason is that I think this is a cyclic quad. It's a little bit of a squeezed cyclic quad, but it is indeed a cyclic quad, which means the reason is going to be opposite angles cyclic quad. So this is going to be 35 degrees up here. Okay, so we have handled the first one. What about R? What do we think R is going to be? PTS is 145, that's 35. What do we think R is going to be? Emmanuel, Owami, and Paul are all saying that R is 35 degrees. And now that I look at it, I actually see the butterfly that is formed by this. And that's a different cyclic quad. But you're right that these two are like peas in a pod. And so we'll say angles in same segment. So we got 35 down there. Opposite angles of a cyclic quad are supplementary. Amartle, I'm not sure you'd be able to do that at this stage for that one. You'd have to go with the angles in the same segment, but you're right with the size. Okay, last one, P2. Where is P2 hanging out? P2 is hanging out over here. So what is P2 going to be? So P2 is 35 degrees, and it's going to be alternate angles PM parallel to SR. Okay, everyone. So what have we done this week? We have just basically got into exam questions. We do need to keep building our knowledge. We want to talk about things called converses. And if there's time next week, we will talk about proofs. But what I do is I do the questions that I think are going to help you the most. And so I'm going in that order because I know these will be the first questions you get in circle geometry exams. and then we'll build up to converses and things like that. If you go too fast in the section, it dents your confidence, and then you don't feel as confident as you need to be. Okay, but I think you're doing very well, and I think you can feel proud of yourself in terms of already you're in exam level questions. Okay, don't understand how we got Q. So for Seni, for finding Q, can you see that this, I know it's looking a bit like a crime scene, but can you see the purple or the pink thing is making a cyclic quad? The cyclic quad has points there, 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 and there. Now, in that cyclic quad, you know the angle here is 45, and the opposite angle to that one is here. And those two together have to add up to 180. Okay.